Okay, this is question number 1.27 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. The problem is a constant current of 3 amps for 4 hours is required to charge an automotive battery. If the terminal voltage is 10 plus T by 2 volts, where T is in hours, how much charge is transported as a result of charging? How much energy is expended? How much does the charging cost? Assume electricity cost 9 cents per kilowatt hour. Okay, so 3 questions are asked here. How much charge is transported? That is the first question. So we need to calculate charge. Charge means it is Q, right? It is in coulombs, right? We need to find out how much coulombs. So what are all given here? If you take a constant current of 3 amps is given. So that indicates it is I. I is given. I is given as 3 amps. And then here you are given for 4 hours. So it indicates it is the time, right? T is given as 4 hours. So what do we need to calculate? We need to calculate charge initially. So Q, what is the relationship between Q and I? I is equal to dq by dt, right? We need to calculate Q now. So Q is integral of I dt. If you know the whole time, then you can take it as I into t. So here it is equal to 3 amps multiplied by this 4 hours. But it should be in seconds, right? So you have to convert it into seconds. So 60 minutes multiplied by 60 seconds. So this is equal to 43,200 coulombs. Or you can also write it as in kilocoulombs as 43.202 kilocoulombs. Okay, so this is the answer for the first part. How much charge is transported? So this is the answer, 43.2 kilocoulombs. Now we go for how much energy is expended. So that is the second part. So energy means it is W, right? W, what is W? W is equal to P into T, right? So we should know the power. So if you want to know the power, you should have the voltage, right? So first we calculate the power. From that power, you can calculate W. P is equal to the product of V and I. And this V is mentioned here. And the V is given here as 10 plus T by 2 volts, right? Voltage. So to find out this W, you can write it as integral P dt. If the whole time is known, you can take it as T. If the whole time is not given, okay, then you can go for this integration. So this W is equal to P is how much? V is given here as 10 plus T by 2. That much voltage multiplied by the current. Current is already given as 3 amps into dt. So 3 is constant, so you can take it outside. Then you can perform the integration. 10 plus T by 2 into dt. So this is equal to 3, 10t plus t square by 4, isn't it? And the limits is 4 hours. It is charging from 0 to 4 hours. That is the time period, right? Time is 0 to 4 hours. So this is equal to 3 times. So you apply the limits. So 10 into 4 plus 4 square divided by 4. So when you apply the lower limit, it is 0. So it is 0 only. So this is equal to 3 into 40 plus this is 4, right? So 44 plus 3, sorry, 44 multiplied by 3. So that is equal to 132. So this is energy, right? So in hours it is. Okay, so it is 132 watt hours. 132 watt hours. So when you convert it into kilowatt hour, so when you convert it into kilowatt hour, that becomes 0.132 kilowatt hour. This is the energy being spent. And what is the cost? The question is, what is the cost? So this is the answer for the second part. Okay, this is the answer for second part. B part answer. Now we go for the third part. What is the cost? How much does the charging cost? And it is 9 cents per kilowatt hour. So total cost is 0.132 kilowatt hour multiplied by this 9 cents per kilowatt hour. So this is equal to 1.188 cents. This is the answer. So we got the answer for the third part also. Okay, thank you. Hope you have understood.